All right, today we're taking on surface area and volume of cones. So first up, we're talking about a cone. It's a type of solid. I cannot use that language of polyhedron here because all of my faces, they're not all polygons. So I have to say it's just a type of solid with one circular base and a curved lateral face that we call a sector. You've always heard me call that like a slice of pie. So the ways that we can look at a cone, we can look at it in 3D, of course. Right, here's my 3D mini cone. And then here would be an example of its net. So I have the base right here, that's that one circular base, and here is my curved lateral face, right? You can see that it's a portion of a larger circle here. So I can curve that together, kind of looks like a little ice cream cone, like that. And then here's my little top, put it down, and I've just made myself a cone in 3D. Okay. So, a cone most closely resembles the pyramid, except the base is a circle, not a polygon. And just like all of the other 3D shapes that we've been talking about, a cone can be classified as right or oblique. Okay, but in this class, just like all the others, we're going to focus on the right cones. Okay, to take care of vocab to start, that tip at the top, we call that the apex. Okay, here, that perpendicular segment that connects the apex to the center of the base, the circular base, right, that's our height. Okay, we have our slant height right here. We had that with the pyramid as well. Okay, and then here, center to any point on the circle, well, we know that is a radius. So I have this triangle that exists inside of any right cone where my legs are the height and the radius, and the hypotenuse is the slant height right there. So when I look at my net, here is my radius. Okay, this part from here to here, that arc length, remember that wraps around the circular base. So if I go back to my net, right, this part from here to here, that wrapped around my circular base. I can see right here how it does that. So I know that from here to here, it has to be the circumference of the base. So 2 pi r. Okay, and then this part right here, that part right there, that's the slant height. So again, if I go back to my net, right, if I look at it like this and I fold it together like that, I can see that, oh yes, that is my slant height right here. So when I unfold it, that is my slant height right there. All right, so I need to go to surface area first. So surface area. So in general, right, we're looking at that curved lateral face. So I need my lateral area plus my base area. But I need to figure out, how do I get to this lateral area? How do I get to it? So let me do a little mini proof off to the side to show you where that comes from. So remember that this is a sector. It's a portion of a larger circle. So let me draw in what would look like as a total circle, just like so. Okay, so we know that when we're solving for the area of a sector, right, it's a portion of a larger circle. So I need to think, well, what is the ratio of this sector to the whole circle? So I'm looking at what's the ratio of right here to the whole circle. So from here to here, this would be 2 pi r. Okay, I know that that length here to here would be 2 pi r. And then for the whole circle, the entire circle's circumference would be 2 pi times the radius as well. But the radius we're defining here is with an L, with the slant height. So 2 pi slant height. So again, that first part is the ratio of the sector here to here to the whole circle here. Okay, and then I multiply by the total area of this circle. So pi times my radius squared. But my radius is defined as the slant height. So pi times the slant height squared. Okay, so now I just need to think, well, how can I reduce this? Well, I can easily reduce the 2 and 2. That's a 1-to-1 ratio. The pi to pi, that's a 1-to-1 ratio. So now what is it I have left? I have the radius times pi times slant height. I'm just writing it out like that, over slant height. So I can see that, oh, well, one of these slant heights can cancel top bottom, and I'm left with the radius times pi times the slant height. Okay, we typically write that as pi r L, pi r slant height. So that is my lateral area, the pi r slant height. So I'm going to write this out just a little bit more clean. My lateral area is pi r slant height plus my base. Well, my base has to be a circle, so pi r squared. So that would be my surface area for any right cone. And for volume, it is the same as it would be with a pyramid, where a pyramid is going to be a third of what it would look like as a prism with the same base area and height. We know that if I compare a cone to a cylinder, it will have the same 1/3 relationship. And if I had my cups of water, I could pour and show you how it's 1/3 of what it would be as a cylinder with the same base shape, same height. So volume would be 1/3 base area times height. So 1/3 base area times height. But I know that my base shape has to be a circle, so I can actually be a little bit more specific and say 1/3 pi r squared times the height. All right, first batch of examples. So find the surface area and the volume of each right cone. So starting off with A. So here I notice that I have the height. Got the height, I've got the slant height. I need the radius. And I actually recognize this as a common triple for a right triangle. I recognize it as a 5, 12, 13. So my radius has got to be 5. And if you didn't see that, you could still use your Pythagorean theorem. That would be fine. I'm just pointing out that we have some common triples that show up that save us some time. So surface area first, I know that that's going to be pi r slant height plus pi r squared. And volume will be 1/3 pi r squared times the height. So I have everything that I need, I just have to plug in. So my radius is 5. I'm going to plug in a 5 for every radius. My height is 12. My slant height is 13. Okay, so for surface area, 5 times 13 is 65. So 65 pi plus 5 squared, so 25 pi. Those are like terms, so I have 90 pi units squared. So 65 plus 25 is 90 pi units squared. Okay, for volume, here I'm taking 1/3 of 25. Let me write that out to see it more clearly. 1/3 of 25 times 12. So I probably take the third of 12 first because 12 is divisible by 3. So I have 4 times 25 and I get 100. So 100 pi units cubed because we're talking about volume. All right, in my next model here, I see my radius is 8, my slant height is 2 root 41, and I'm going to need my height. So here I don't recognize the common triplet at all, so I'm going to go ahead and use Pythagorean theorem. So I have 8 squared plus my height squared equals 2 root 41 squared. So 64 plus the height squared equals, well, that's 2 times 41, so 164. Take away the 64 from each side. The height squared equals 100. Take the square root of each side. Well, the height could be plus or minus 10, but we're only interested in the positive. So the height has to be 10. So now I have everything that I need to be able to solve. So surface area, let me lay that out. Pi r slant height plus pi r squared, and volume 1/3 pi r squared times the height. So here I can plug in my radius first, that's 8. My height is 10. My slant height is 2 root 41. Okay, so now as I multiply across, I have 8 times 2. So I have 16. I put the pi next just so it doesn't get interpreted as part of the radicand, the number underneath the radical. And then I put the radical part last. And then plus 64 pi. And then of course we're talking units squared. Okay, they were not like terms, so I couldn't consolidate. Okay, next I'm taking 1/3 of 64 and then multiplying that by 10. So I end up with 213 and 1/3 pi units cubed. You could always leave that as improper as well. That is perfectly fine. I just made it a mixed fraction right away. All right, and then here I'm giving you a sector here, right? I'm showing you what it looks like in 2D. I'm showing you what it looked like as a net. So remember that this part here is the radius, right? Radius of the base. And then right here, this is the slant height. So let's picture this 3D. So right now I have my cone where I know that my radius right here is 6 and my slant height is 12. And I know that I'm going to need my height for the volume. So this is what I have so far. So hopefully we recognize that's a common 30, 60, 90 triangle pattern. So I can see that this is x and this is 2x. So right here would have to be x root 3. So if I recognize that that's a 30, 60, 90 triangle because I see a leg with a hypotenuse that's double, right, I can see that my height has to be just the x root 3, so 6 root 3. And if I didn't, I would just use Pythagorean theorem. It's not a problem. All right, so now I have everything that I need. So surface area, pi r slant height plus pi r squared. Volume, 1/3 pi r squared times the height. My radius is 6. So I'm going to plug in a 6 for each radius. My height is 6 root 3. My slant height is 12. Okay, so starting off with surface area. 6 times 12 and I get 72 pi. 6 squared pi, I get 36 pi. Combines to make 108 pi units squared. Okay, volume, I'm taking 1/3 of 36, so I have 12. 12 times 6, and I get 72. Okay, pi next, radical last. So I have 72 pi times the square root of 3 units cubed. Okay, flip it over to the next sheet. Right here. All right, a right cone has a radius of 9 centimeters and a surface area of 216 pi centimeters squared. Find the slant height. So let's visualize it. You know, I love a visualization. We are in geometry after all. So here is my right cone. I am told that my radius is 9 and my surface area is 216 pi. I'm trying to solve for the slant height right here. So I'll mark that with that cursive L because that's what I want to solve for. So we're told the surface area. So maybe lay out the surface area formula. Surface area is pi r slant height plus pi r squared. Plug in what you know. We know the surface area is 216 pi. The radius is 9, so 9 pi times the slant height, plus pi times 9 squared, so 81 pi. Okay, so keep in mind what we're trying to solve for. We're trying to solve for the slant height. So I need to combine any like terms that I have. So I'm going to take away the 81 pi from each side. So I get 136 pi equals 9 pi times the slant height. And then I just have to divide each side by the 9 pi. So 135 divided by 9 gets me 15. So my slant height is 15 centimeters. Okay, let me slide it up. Go to the next one. The volume of a right cone is 1,680 pi centimeters cubed. The radius of its base is 12 centimeters. Find the height. Okay, so again, I like to visualize what I'm trying to solve for. So here is my right cone. We're told that the radius of its base is 12. So the radius is 12, and I want the height. Okay, so I'm solving for the h. So we're given volume. So volume, it's a cone, so 1/3 pi r squared times the height. Okay, we know volume is 1,680 pi is equal to, radius is 12, so I'm taking 1/3 of pi, and then 12 squared is 144 times the height. Let me just clean up the 1/3 times 144. So 1,680 pi equals, well, 1/3 of 144 is 48. So 48 pi times the height. So now I'm just dividing each side by 48 pi. So I'm really taking 1,680 and dividing it by 48, and I'm going to get 35. So my height is 35 centimeters. Okay, next up. Okay, the surface area of a right cone is 300 pi centimeters squared. The slant height and the diameter of its base are equal. We want to find its radius. So slant height and diameter of its base are equal. Find its radius. Okay, so first I'm just going to lay out my formula. I know that surface area is pi r slant height plus pi r squared. Okay. And I know that the surface area is 300 pi, so I could go ahead and plug in the 300 pi right here, but then I get a little stuck. I'm trying to solve for the radius, so I need to think about what is this relationship telling me. Slant height, diameter of the base are equal, so slant height is equal to the diameter of the base. Well, I know that my diameter is equal to 2 radii, right? So 2 times the radius value is the diameter. Okay, so then I could use a little transitive property or substitution and then make the length that the slant height is equal to 2 radii, or 2 times the radius. So if I can see that connection, then I can actually convert all of my variables here into r, the radius. That's what I'm solving for. I can then plug in right here for the slant height 2r, since my slant height will be equal to 2 times the radius value. So now let me plug that in and then see what it takes to solve. So 300 pi equals pi times r times 2 times r. So 2 pi r squared. And then here pi r squared. So I actually have like terms here and here. They both have a pi r squared. Here I have 2 of them, here I have 1 of them. So I have 300 pi equals 3 pi r squared. So now again, it's just an algebra problem and I'm trying to solve for the r. So I can divide each side by 3 pi. My radius squared is equal to 100. I solve by taking the square root. I know that it could produce plus or minus 10, but my radius, it's gotta be the positive. So my radius is equal to 10 centimeters. All right, one more problem. So find the surface area and the volume of the composite solid. So whenever we call something composite, that just means that we're looking at 2 figures together or more. So in this case, we have a cylinder. We've got a cylinder with a cone up on top. So it looks like that. So if I first focus on my surface area, I want to make a game plan for how to get to surface area. So surface area, I'm starting with my cylinder. So I'm starting with my cylinder. And I want all of the surface area, but I have to take off that top part because that part's not exposed when the cone is on top. So I need my surface area of my cylinder, but I need to take off that top base. So I'm looking at my cylinder minus 1 of the circular bases. And then in terms of the cone, what part is exposed? Well, only that curved lateral face is exposed. So I need to add the cone's lateral area. Okay, so here my cylinder surface area is 2 pi r h plus 2 pi r squared. So there's my full cylinder, and then I have to take out one of those circular bases, so minus pi r squared, and then I have to add in the cone's lateral area, which is pi r slant height, like that. So if I plug in everything that I know that my radius is 3, I know that my slant height is 5, so my height, I can also fill that in since I recognize a 3, 4, 5 triangle. 3, 4, 5, like that. Let me draw that to the side. The most common Pythagorean triple that we have. Okay, so for the cylinder though, cylinder first, radius is 3. And for the cone, radius is also 3. Okay, height of the cylinder right here is 5. And let's see, slant height of the cone also 5. Right, but here's the height of the cylinder, and here's the slant height of the cone. All right, so right here, 2 times 3 times 5 gets me 30 pi. 2 times 9, 18 pi. Okay, so I have 30 pi plus 18 pi. That's my whole cylinder, but I want to take away one of the circular bases. So I'm going to take away the 9 pi. So that gets me my whole cylinder, but not that top base. Okay, and then I need to add in just that curved face of the cone. So here I'm going to add back in 15 pi. So I really have 30 pi. Here's plus 9 pi plus 15 pi, which will get me in total, so 30, 18, so 48 minus 9 plus 15, I'll get 54 pi square yards total. Okay, volume. Volume's easier, right? Because volume has no cutouts. Volume is going to be just the cylinder plus the cone. So my cylinder, pi r squared times the height, and my cone, 1/3 pi r squared times the height. So for the cylinder, my radius is 3, and the height of my cylinder is 5. For the cone, radius is also 3, but the height of the cone right there is the 4 right there. So here I have 3 squared times 5, so I have 45 pi. And here I have 1/3 of 9, so 3 times 4 is 12, so 12 pi. Gets me 57 pi yards cubed. All right, that's all I got for the cone today. I hope you guys have a good rest of your day. I'll see you soon.